Okay, initially we start with the basics of electric vehicle. What is electric vehicle? That is about e-mobility. This instead of using the IC engines, we are going to use the electric motors for the propulsion of the vehicle. Instead of the fossil fuels, here we are going to use the rechargeable batteries. Yeah, actually, there are some the electric vehicles types like two-wheelers, three-wheelers, and four-wheelers. Depends upon the usage and the type of the people's required. And the vehicle types is varied. Mm, okay. In the four wheelers, there are four types. This is normally the conventional vehicles. The conventional vehicles are the one we are currently using. Another one is the hybrid vehicles, and the next one is a plug-in electric hybrid vehicle. The last one is electric vehicles. In this, the conventional vehicle, the thing is we are using the fossil fuel for propulsion of the vehicle. As you know, the internal combustion engine, the fuel and air will mix, and it will start ignited, and the engine will start, and the vehicle will run for it. And in this, the main advantage is there is an easy refuel of the uh, fossil fuels, as we have a number of petrol banks in our country, so we can easily refuel the vehicle. And the most disadvantage of this is emission of CO2. So, and the fuel cost is day by day it is increasing. And another thing is the fossil fuels are depleting every day due to the overconsumption. And the next, the hybrid electric vehicles. In hybrid electric vehicles, there are two modes of propulsion in this. The engine will act as a primary that will use the normal fossil fuels, and the motors, that is the electric motors, it will act as a secondary. In this, advantage is it is also easy to refuel, and major advantage one of the hybrid electric vehicles, the consumption of fuel will be reduced. For example, if you take then the hybrid electric vehicle in the current market, like Ciaz, it is an hybrid electric vehicle from Maruti. In this vehicle, if you go with a speed of some 35 to 40 kilometers, it will take the motor will act as an propulsion, and it will act as an electric vehicle. When you go beyond the speed of some 40 kilometers and all, it will the propulsion will move to the engine, and it will run with the fossil fuel. And another and the major disadvantage of this, the weight of the car will be heavy, because the fuel tank will be there, the batteries will be there, so the size of the batteries, the size of the engine, everything will be increased, so the weight will be increased in this. And it will also use for long run, like long run means because easy refueling is there, so we can go for long run. Another thing is plug-in electric vehicles. In the plug-in hybrid electric vehicles, there are two things. One is the motors will act as a primary thing. It will have a separate set of propulsion with battery, inverters, everything will be there, charging port, everything will be there. Another set, it will have an engine with an fossil fuel tank, and the engine propulsion systems will be there. This both will be there, so the weight of the vehicles will be increasing this. And another thing, it is easy to refill once if the battery is gone. The people can use it with the engine as a secondary one, and they can go for a long run using this plug-in electric vehicles. But while coming to the cost and the weight of both will be high, like it has a high price, and also the weight of the car will be higher. And the all-round, we are going to see about the a full electric vehicle. In this, there won't be any fossil fuel in this, or any engine will be in this. Main will be the main propulsion system will be a motor. That is, it will be the energy backup will be taken from the battery, and we will go for an eco-friendly run. But the main problem in current scenario, like the 2020, like in the current scenarios, we have lacking of charging stations, and we cannot go for a long run. For example, if one electric vehicle is capable of running up to 300 kilometer, you can go up to that only. Before that, after reaching the 300 kilometer, the charging is very necessary. So if due to the lacking of the charging stations, we cannot drive for the long run. So this is the major problem in our country, the current scenario. So the government has been set up more regulations and funds, many project funds, everything for setting up the charging stations with currently they are working on the regulations also. Okay, while coming to the components, what are the components in the electric vehicles? In the normal vehicles we have the engine, uh, fuel tank, fuel propulsion system, igniter, everything will be there. While coming to the electric vehicles, here most of the components are based on the electric, like electric motor will be there, and for operating, for driving the motor we need inverter. Then for the backup of the power we need a battery with BMS, which should have inbuilt BMS with cooling system should be there, and the thermal management should be maintained in this. And another thing, the DC-DC converters. The DC-DC converters is required for direct charging of the system, or for supplying the auxiliary components in the electric vehicle. And another thing, so onboard charger. This onboard charger will be in any type. It will be direct DC charger, or will be an AC charger. It depends upon the manufacturers and and the vehicles. And as usual, the foot pedal, relay, and all the things will be in common. uh, Oil pumps, everything will be in common as normal vehicles. Before we see about the block diagrams, now we are let's see that how the charging will be taken. Charge will be taken from the grid, and how it will be charged to the electric vehicle, and how the electric vehicle operations are carried out. For example, initially the power from the grid, there may be two types of charger. Onboard charger, it will be the power will be taken directly, the AC will be taken from the grid, and there will be an AC to DC converter. Then it will be given to the propulsion battery, or else we can go for fast charging. There is fast DC charging. In this, the AC power from the grid will be taken, and the charging station itself, there will be an AC to DC converter which having capacity of fast charging, and directly the DC will be given to the propulsion battery for charging. And the one of the key advantage of the fast charging is the time consumption will be very less for charging the full capacity of the battery. Then from there will be an DC-DC converter. Initially, we go with the electric vehicle with the electric machine. In this, the electric machine converts electricity to the torque for moving the vehicle. And this, we can simply say the electromagnetic field will be there, and we create the torque, and the electric vehicle will be moved. And based on the manufacturers and the design, some of them are using induction machine, some of them are using PMSM, and even two-wheeler, in the two-wheelers they are using BLDC based motors. While going for the four-wheelers, mostly they will use induction machines and PMSM. Okay. For operating the electrical machine, we need an inverter, because the power supply in the power supply you obtain from the battery is mostly in DC. That is why high voltage DC. That high voltage DC will be converted into the AC signal. That is a battery from DC will be converted into AC using an inverter mounted over the motor. As we the diagram shows that there will be an induction motor here. Then over that they place an inverter, and over that they place an DC-DC junction box. In this, this is the motor module they will place inside the electric vehicle. Like from the DC-DC power will be given to DC power will be given to the inverter. Then it will drive the motor. And mostly the while choosing the electric motor, they will see the efficiency of about 90%. If the efficiency goes down, the consumption of power will be increased, and we won't get the long run in the electric vehicle. So they mainly see the efficiency of the motors. Then, well, the main source of the electric vehicle is the battery pack. The battery pack is the it's a major it's a main part of the electric vehicle. It and the electric that sorry that battery pack should able to store a high amount of energy, and also the battery management should be proper. For example, the while charging or discharging, the battery cells will get heated, so the thermal management should be proper, and the proper alignment should be there. Thermal management and the cooling should be there. Some of the battery BMS they are using liquid cooling, So the cooling of the batteries and thermal management, everything is should be proper, then only we'll get the proper output. Also the long run will be there. In the again we can show the battery pack with the mechanical enclosure. The individual cells are there. Individual cells are coupled to make in modules, and that module is connected to the BMS, and the BMS will take care of all the thermal and electric charging and discharging process. In here I show a small comparison, that is based on the models from Toyota, Mitsubishi, BMW, Nissan, Tesla, everything. This, what's the battery they are using and what's the charging time. The first one Toyota, if you go with that, they are using 4.4 kilowatt lithium ion battery, and the charging time is 3 hours if you use AC of 115 volt. If we use the 230 volt AC, it will be about 1.5 hours. Like these are the normal charging thing. While going the latest vehicles like Tesla, they are using about 70 kilowatt or 90 kilowatt battery, depends on the vehicle range, and it is a liquid cooled battery. And also the charging is if you use a 10 kilowatt charger, the slow charger, it will take 9 hours. If you use 1 kilowatt supercharger, is a fast charger, it will charge within just 30 minutes. Same Tesla 3 also, if you use DC charger, it requires just 30 minutes. If you go with the Nissan i3, sorry, BMW i3, same. If you go with the DC fast charger of about 50 kilowatt, it's just take 30 minutes of charging. The main advantage of DC charging stations are the is the time consumption for charging is very less.
Time consumption for charging is very less.
These are the small comparison of the electric vehicles
Comparison of
available in the market. In this like Ford I take some four
like
examples,
food
like Ford Focus electric vehicle, it will go up to 76 miles, and the Fiat 500 EV that will go up to 87 miles. Then Honda Fit EV, it will go about 82 miles of range, and Chevrolet Spark, it will go about 82 miles. Then we go to the inverter part, uh, electric motor inverter. The battery pack is the main source for this, and the electric motor is fully controlled by the this inverter using the alternating current. The battery, the power from the battery is converted into AC power. DC power is converted to AC power. Then the torque control, the speed. Well, what is the instruction, like the the driver is accelerating the pedal. Like if you need to increase the speed, if they accelerate more, the command will change, and the motor drive will give more power to the vehicle, and it will run faster. Based on the instruction from the driver side, there is usually we say longitudinal drivers in technically as our driver input. Based on the driver input only, the power given to the motor will vary. Then as I said, there's a AC charging is directly we take power from the electric grid, and it will given to the uh, rectifier, that is rectification, but AC voltage connected to DC voltage. Then we will connect the charger to the vehicle. Okay, in this diagram we can able to get that the AC power is there, and there will be a communication and control part will be there. Then it will be given to the electric vehicle for proper charging. Like the reason for control and communication is each vehicle use each type of protocols for their protection. For example, if any problem occurs in the grid side, the charger will automatically isolate from the supply. So depends on the features and protocols they are using, like CAN protocol or anything. Based on that, the communication will changes. And also now most of the companies are working towards the bidirectional charges for allowing the energy transfer to the grid at the peak time. For example, in the previous charges there will be unidirectional. We can just take the power from the grid and we will connect to the vehicle. But the bidirectional charger, we can give supply to the grid when there is an peak load or any emergency is there. Okay. Then we'll go with the DC. Sorry, here I mentioned as AC charging. It is actually DC charging. In the DC charging, as I previously showed that DC charging will be an high capacity charger with slow charging time for the vehicles. And in this, the AC to DC converter will be in the grid side itself, that is the charging station itself. And through a communication and control cable, we can connect the vehicle and we can charge it efficiently. Okay. Then there will be low voltage DC-DC converter in this for supplying the auxiliary equipments in the vehicle. Uh, for example, if you go with some audio systems or a lighting system, we need a low voltage DC in this. The battery pack will be the output of the battery will be an high voltage DC of some 300 volt or 400 volt, but we cannot directly feed that to the auxiliary supply. So here there will be DC-DC converter for using the low voltage applications like electrical lights, audio systems, um, basic accessories in the vehicle. And we'll go then we before we saw about the four wheelers and what are the types and how it can be used. How the charging will be used, AC or DC, and what are the advantages of AC, what's the disadvantages of AC. I will just see about the outline of two wheelers. Here the two wheelers we have conventional vehicles and electric vehicles. As the conventional vehicles, it will be using fossil fuels. In petrol, that is in petrol, it produces harmful CO2. And the other advantage is it's a long run. But while going to the electric vehicle, there won't be any long run. Here the short run will be there, but while seeing the CO2 emission or maintenance, everything, it will be eco-friendly. But due to the lacking of the charging stations, we are not able to go for a long run in this. The easy refueling of the easy charging, that is the refueling, is not possible due to lacking of the infrastructures. Here now we're going to see about the electric market. That is how the global electric market in 2019, the statistics and forecast. Now the most of the countries are focusing on the electric vehicles. In this, you can see the graph from 2010 to 2018. There's a drastic increase in the growth and selling of the electric vehicles. Literally 64% of increase is there over the past 10 years. And when you take the how the market size of the cars in 2018, it's literally doubling from the 2017 to 18. Also from 18 to 19, there's been more increase in the vehicle sales. So most of the manufacturers of the cars and the companies with the governments are supporting the sales of electric vehicles to make the globalization eco-friendly and reduce the CO2 emission. And the EV 2030 scenario, in this, most of the countries like Canada, France, Japan, Norway, Chile, through Netherlands, Sweden, China, UK, Finland, they are forming this 13 countries form a committee for EV 30, and they are planning for the increasing the sales of electric vehicles to 44 million per year by 2030. It's literally called as EV 2030 campaign. They have planned from 2018 to 2030 to increase the sales of electric vehicles. From you can see here about 20 million cars are been sold in 2018, and they are planning for 250 millions of cars should sell in the 2030 mission. And some of the governments has been planning for banning the IC engine cells by the years. For example, in China, they already actively banning the IC vehicles. France, they are planning for 2040. German, they plan for 2030. India, they are planning for 2030. Ireland also 2030. Israel, Netherlands, they are also 2030, planning for 2030. Then we go for Norway, they are more advanced and they are planning within 2025 to ban the IC engine sales of IC engine vehicles. And Scotland, they are planning for 2032. UK, they are planning for 2040. So some of the countries are planning for banning the sales of IC engine vehicles. And some of the states in the US also, they giving them incentives for the user electric vehicle users. For example, if you take the California, if you have electric vehicle using the electric vehicle, they will give in rebate of $2,500. And while you are going with you can take example of Maryland, they are giving a tax benefit of about $3,000, and also $700 for installation of the connectors, like charging chargers. And well, taking the whole USA, they are about giving about 7,500 tax benefit for the units of up to 2 lakh units sell by the like first come first serve. If you get a car within that 2 lakh cars, you will get a tax benefit of about 7,500 per year. So, and while coming to the India, they are planning the EV 2020. They plan the EV 2020 mission, like National Electric Mobility Mission Plan 2020. In this, while comparing with the Chinese and Norway, they are rapidly approaching the reduction of sales in the IC engines, and they'll increase the sales of EV. Like uh, they're planning to increase the sales by giving the subsidies. Now also you can get subsidy for the electric vehicles. Like if you go with the Hero two wheelers, there is some subsidy. It's around I think some 10,000. I think that's where subsidy is there. Before implementing the EV, there are certain things we need to consider. The first one is we need to increase the power generation by using the renewables, because if you use same fossil fuels for the generation and we are using it for the electric vehicles, there won't be any reduction in the CO2, because the same level of energy is required for the EV also, while obtaining that from the fossil fuels. So they are penetrating the renewables to the grid. And also they are boosting the rooftop solar generation. The third one is they are encouraging the EV manufacturers for changeable batteries. That's changeable batteries in the sense there will be a moving charging station. um, for example, the swapping stations, there are some swapping stations, the battery swapping will be there. If the batteries get drained, you can just replace your battery in that. There replace the battery with full capacity. And what the plan of that is, they are the charging stations are advised to charge at the half peak time. For example, if you charge the batteries at the peak load time, the consumption, that is the charges will be high, the tariff will be higher. So in order to reduce the tariff, the charging stations are advised to charge at the off peak time. For example, in India, the for night after 9 p.m. that half peak time. Before 6 p.m. to 9 p.m. it will be in peak time, because most of the lights and TVs and all the household equipments will be in on condition, so it will be in peak time. And also they are planning for the dynamic pricing. The dynamic pricing is depends upon the load peak times, the using the smart grid control. They are planning for the charging of sorry planning for the tariff of the charging stations. These are the main key points they are planning while considering the grid side for charging and all. While you, okay, like penetration of renewables, then battery swapping stations, and how the battery should be recycled, and how the intelligent charging stations. For example, if you go with a single charging station, there won't if some other is occupied, that you cannot be able to use that. So there will be intelligent charging stations. Like if there is an 50 charging stations in a town, everything will be interconnected through an intelligent app, and uh, we can easily check the availability of the charger, and also we can book the charging station at a particular time, whatever the time you required, and you can book the charging station on the time, and you can go and utilize that. Like that, there are some intelligent charging stations also there. And now the government is planning for the recycle of the batteries. They framed some regulations in 2001 itself for eco-friendly recycle of the batteries. And also now government is giving more funds and investments in the R&D for booming the EV activities. And this is an sales predicted in India for in 2026, that is 6 years after. What will be the sales? It's the prediction is done by Society of Indian Automobile Manufacturers. You can see the numbers, how in 2016 to 17 and 2026 how it has increased. They are predicted to increase for two wheelers, for fleets, like fleets when fleets of trucks, commercial vehicles, two wheelers and three wheelers. These are the predicted sales at 2026. The prediction was done at 2016 to 17 period by the Nidhi Aayog. Okay, then and in the previous slides we just discussed about the basics of electric vehicle, four wheelers and two wheelers, how they charging, what is the mission of electric vehicle 2030 around the globe and around India, how they are planning everything. Now we are going to see about the charging methods, that is AC charging or DC charging, battery swapping, how they are doing. First we take an on charger, that is an AC charger. It would be an slow charging, and also we say it as an overnight charging. Second, we go with an off-board charger, that is an DC charger. It is an fast charging. The next one is battery swapping. The battery swapping requires two things. One is the battery should be able to communicate with the charger. There is a communication protocol should be same. Another thing, the standardization. For example, if you give a 20 kilowatt battery for charging, they must give 20 kilowatt battery, like that. There will be a standard should be followed. We go to the next one. As I say, there will be an onboard charger. The onboard charger is of about it's also called as level 2 charger, and in this we will use single phase or three phase supply, and it may be in private or public. and and it is an AC charger. Another thing, onboard charger, it is an level 1 charger. In this, the voltage, single phase voltage of 120 volt. Here in the level 1 charger, there won't be any communication protocol connected to the vehicle and the charger. But in the level 2 charger, we have the communication protocols for connecting the vehicle to charger. It's a level 3. It is a level 3 is an, the input will be three phase AC, and there will be a separate AC to DC converter in the charging station itself, and we will, the DC will be directly connected to the electric vehicle. In this also there is an communication protocols, and for control and communicating the chargers and vehicles. The charging methods, as we say, the AC level 1. The AC level 1, the nominal supply will be 120 volt of single phase. The current may be of 12 ampere or 16 ampere, depends upon the manufacturers, but the estimated time is 17 hours for charging, so only it's called as overnight charging. And and another thing, in AC level 1 there won't be any communication protocol connection between vehicle and the charger. In the AC level 2, it will be of single phase 208 to 240 volt range, and the maximum current will be 80 amps. And in in the AC2 level 2 charger, there are three types. One is 3.3 kilowatt, it is an 7 hours charger. Another one is of 7 kilowatt, is about 3.5 hour charger. Another one is 20 kilowatt, it required 1.2 hours for charging the full capacity. And next one is DC level 1. In DC level 1, we have DC input of 200 to 500 volt. It will be very depends on the manufacturers, and the maximum current will be 80 amps, and also the output power will be 40 kilowatt. In this, the time required for charging is 1.2 hours for a 20 kilowatt charger. If it is an 40 kilowatt, there will be in some 30 minutes only. So it depends on the capacity, the charging time will be reduced. Another thing, there is a DC level 2. In this, the maximum current required will be 200 amps, and it just requires 20 minutes for charging. So kindly mute. Okay, then there's four modes of charging. Starting from the for AC or DC, there's four modes of charging. In the mode one, as I say, there is an it's literally equal to AC level 1. The AC level 1, there won't be any communication protocol between the charger and the vehicle. And this, it is just an home plug. We can go with some 16 amps ampere for plug point, and we can charge easily. And in this, there won't be any protection against the DC. There will be protection against only AC due to the household connection. There won't be protection against the DC, because it will have an onboard charger. The DC conversion and the protection, everything will be taken care by the DC, by the onboard charger. Then mode 2. In mode 2, it's also a charger. It's an household charger with control and communication part. In this charger, there will be special cable integrated with the uh, charger, which has an protection against AC and DC currents. This type of chargers are commonly used nowadays for the vehicles. It is the same as mode 1. It is also household connection. It's a household connection. Then if you go with mode 3, mode 3 is mode 3. There will be control and communication will be indigenous between the grid and vehicle. That is, there will be a separate wall mounted charger will be placed in our home or our office, and there will be a proper protection against both the AC and DC. And you can come across that Ether wall box charger while going with while buying the Ether vehicle. They will give a wall box charger with Ether. This that charger is all of this type only. There will be a proper communication between the control communication between the wall charging and the chargers and the vehicles. So in this, it will be act as an AC charging station. And if you go with the mode 4, the mode 4 is a DC fast charging station. In this, as I said previously, the AC rectified part, everything will be in the charging station side, and directly we can connect our charger cable to the vehicle, and we can charge fastly while comparing with the AC chargers. Okay. We previously just I recall the things, the basics of electric vehicles we saw. Then we come with the vision of electric vehicles. Then we saw about the types of charging from mode 1 to mode 4. Okay, the charging stations they are planning for setup, but they need some regulations for setting up the charging stations. Here we are going to see about the charging station AC001, the public type 3.3 kilowatt charger. Initially, the draft has been released at 2015. Then they finalized the draft, the regulation at 2017. The regulation named as AIS 138. The AIS 138, there are two types of chargers. They think AC slow charger and AC fast charger. The AC slow charger, there will be single phase supply with the 15 amps, maximum 15 amps current, with protection equipments like RCD protection and mandatory safeties for wires and stations will be there. If you go with the AC fast chargers, they are here they are utilizing three-phase supply with maximum of 63 ampere. And in this, the main thing is they will have a control panel, that is the fast charging with control and communication will be there. And the battery safety equipment has been placed in both the chargers. And what are the mandatory safety functions we required for a charging station? There should be an earth presence detection, over voltage detection, There is protection and detection of that. The under voltage protection, over current and short circuit protection should be there. And also we need to protect the charger from the leakage current at earth of RCD type of 30 milliamps. And also environmental protection should be there. Phase neutral interconnection, if any changes in the phase or neutral, it should also protect the, there should be protection from the phase neutral interchange also. Then then the protection against the electric shock. For example, if we just place a charger, the charger should not be the live parts, that is the parts which are conducting the electricity, should not be accessible to the consumer who are going to charge the vehicle. So the live parts of the electricity should be kept inside the proper closure. That closure should not conduct the electricity. So proper like reinforced insulation should be there. The protective equipment potential should be there. Protective screening. So the protection the protection against electric shock should be taken care. So there should be no hazardous parts in live, hazardous live part should be contactable to the consumer. And also if any disconnection happens, there should be proper discharge of the if any capacitor is placed inside the charging station. And while coming to the sockets and cables, the socket which you are using should get approval from the IEC 60309 standard. And also cable, it will depends upon the, like for example, if you go with on 3.3 kilowatt, the range will be different. If you go with 7 kilowatt, the range will be different. So depends upon the requirement ratings, the cable should be taken. And another thing is EV, electric vehicle supply equipment requirement. In this thing, the charger should um, uh, the charger should have an dust protection like that IP21. If some chargers we can place in outside, or it will have some different standard. If we go with the charger of AC001 type, it should be an indoor charger with IP21 protection. And also the every charger should have, charging station should have an emergency button for easy isolation when against any disconnection or any fire or any problems in the charging station. The charging station we discussing is AC001 type. In this, will be it will come under IP21. And also we need to take care of the temperatures. For example, the grasping parts, there's a grasping parts means the accessible parts to the uh, consumers, that should be non-metallic with the maximum of 60 degree. It should not go beyond 60 degrees centigrade. And uh, not grasping metals. For example, inside the charging station, you will keep some of the equipments and all. It should not it should not also non-metallic, but it should not go beyond 85 degrees centigrade. So that should be taken. And another thing is where we can place a charger. It should be 1.5 meters from the floor. Then there are some basic requirements for the electric vehicle supply equipment part. In this, there should be an dielectric withstand characteristics, insulation resistance should be there, clearance and creepage distance, that is the distance which you are placing, that it should have 1.5 meters from the floor to the chargers. And there should not be any leakage or touch current. Earthing electrode should be connected properly, and there should be proper continuity in that. Before placing the charging station, we need to check the charging station for the environmental test. Initially, they will blow an air of 0 to 55 degrees centigrade, varying air temperature for 1 hour and 2 cycles. Then they will blow an heat air of 55 degrees centigrade for 16 hours. Then they will change the ambient humidity of 5 to 95 percentage. And these are the varying air temperatures from 0 to 55 degrees centigrade, and the humidity they are changing. Also, the charger should run at, that should operate at 0 degrees centigrade. So they test the charging station at for 16 hours under 0 degrees centigrade. Another thing, they will the charging station should not affect due to the solar radiation. So they what they will do means they will they will expose the heat of 55 degrees centigrade over the charging station, and that will be kept for 20 hours and 10 cycles. And another thing, if any rain or any mist, like the saline mist, any problem is there, it should not also the charging station should also capable of working under the saline mist of 2 hours per uh, and 22 hours of testing under 3 cycles. And all the components should have an mechanical strength. So to check the mechanical strength, the impact of the material impact of 5 kgs thrown over the charging station, while throwing that it should not get damaged. And also they will make a stability test of 50 kilograms for 5 minutes. While applying the 50 kilograms of stability test, the applicable changes in the charging station is 50 mm while applying and 10 mm while taking the load of 50 kilogram. So the for example, if you place the 5 kg 50 kg of weight over the equipment, the acceptable limit is 50 mm. It can change, that is it can bend or anything, but while releasing that, the acceptable uh, change would be about 10 millimeter. So it should retain its own structure. And while going to the IP test, it should go under IP23 standard. As I said before, IP21, that is for internal ports. It is IP23 for the external port. And the charging station should undergo the electromagnetic test. The charging station should have an immunity for electromagnetic disturbances, electrostatic discharge, high frequency connected disturbances, and if any problem occurred due to the radiated electromagnetic disturbance, everything should be um taken care. So the charging station should have immunity of all the electromagnetic disturbances, and it should not emit more electromagnetic waves also. That should also be taken care in this. And then the we know that usually if you take some electric equipments, there should be nameplate details. So here also the set of instructions for giving the nameplate details: manufacturer name, equipment reference, serial number, date of manufacturer, rated volt, like voltage, what are the heads using, amperes and number of phases, whether it can be used for indoor use or outdoor use. So what type of equipment, like it's an AC slow charger or fast charger. All the details should be there in the nameplate details. And one thing in this is, if you it should not erase easily. For example, if for testing they will pour an petroleum sprit and they will rub for 15 seconds. Even that, in that time also, it should not erase. So these are some standard testing for before getting the approval for the charging stations. And also the manufacturer should taken care of the periodic compliances. For example, if any mechanical conditions like abrasion, oxidation, or carbonization due to the uh, due to exposed to the air or anything, the materials inside may get corrode or anything, the problems will come. So they should taken care of that with periodic compliance. Also, while coming to the electrical thing, the isolation resistance, functioning of OCD, that is a residual current detection, everything should be taken care, and they should uh, do the periodic compliance, that is periodic maintenance should be there. And as of now, we saw about the electric vehicles, charging stations, and regulations, Indian regulations for AC 001.